Warm greetings to one another. I'm Sai Parmeshwari from CSCA and researcher. Today we are going to discuss a topic about an encoder encodes the first 16 lower cases, first letter using 4 bytes each. The first byte of the code is 0. If the letter lies among the first 8 letters, else it is 1. Significantly, that is lies among the last 8 letters. The second byte of the code is 0 if the letter lies among the first 4 letters of the of those 8 letters found in the previous step, else it's 1, signifying that it lies among the last 4 letters of those 8 letters. Similarly, the third and the fourth byte each signifying the half in which the letter lies. For example, the letter J would be encoded as among A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. J appears in the second half, so the first byte of its encoding is 1. Now, among I, J, K, L, M, N, O, P, J appears in the first half, so the second byte of its encoding is 0. Now, among I, J, K, L, J appears in the second half, so the fourth and last byte of its encoding is 1. So J's encoding is 1001. Given a binary encode string S of length at most 105, decode the string. That is, the first 4 bytes are the encoding of the first letter of the secret message. The next 4 bytes encodes the second letter, and so on. It is granted that the string length is a multiple of 4. Here, I gave the content that we are going to discuss in this topic. Introduction, overview, description, encoding plain text, encoding standard notes, program conclusion. Introduction. A binary to text encoding is encoded of data in plain text. More specifically, it is an encoding of binary data in a sequence of printable characters. These encoding are necessary for transmission of data when the channel does not allow binary data or is not a clean. PGP documentation uses the term ASCII armor of binary to text encoding when referring to base 62. Overview. The basic need for a binary to text encoding comes from a need to communicate arbitrarily binary data over discrete communications protocols that were designated to carry only English language, human readable text, whose communication protocols may only be 7 bytes safe and may require line breaking at certain maximum intervals and may not maintain white space. This only the 94 printable ASCII characters are safe to use to convey data. Description. The ASCII text encoding standard uses 128 unique values to represent the alphabet, numerical, and Protenses character commonly used in English plus a sectional of control codes which do not represent printable characters. For example, the Capital letter A is ASCIL character 65. The numerical 2 is ASCIL 50. The character is ACIL 125 and the meta character carries return is ASCII 30. System basic on ASCII uses 7 bytes to represent these values digital. In contrast, most computers store data in memory, organized in 8-bit bytes. Files not contain machine-enabled code and non-textual data type contain all 256 possible 8-bit values. Many computer programs come to rely on this destination because 7 bytes text and 8-byte binary data and would not function properly if non-ASCII characters appeared in data that was expected to include only ASCII text. For example, if the value of the 8 byte is not prevented, the program might interpret a byte value about 127 as a flag telling it to perform some function. It is often disabled, however, to be able to send non-textual data through text-based systems, such as when one might attract an image file to an email message. To accomplish this, the data is encoded in some way, such that 8-bit byte is encoded into 7-bit ASCII character. Upon safe arrival at its destination, it is then decoded back to its 8-bit form. This process is referred to as binary to text encoding. Many programs perform this convention to allow for data transfer, such as PGP and GNU privacy guard. Encoding plain text. Binary to text encoding methods are also used as mechanism for encoding plain text. For example, some systems have a more limited character set they can handle. Not only are they not 8-bit plain, some cannot even handle every printable ASCII character. Otherwise, system have limits on the number of characters that can appear between line breaks, such as the 1000 character per line limit of some SMPP software as allowed by RFC 2821. Still other add headlines or trails to the text. A few poorly regarded but still used protocols uses in the ban signaling causing confusion if specific partners appear in the message. The best known is the string from at the beginning of line used to separate mail message in the inbox file format. By using a binary to binary encoding on the message that are already plain text, then decode one can make surely system appears to complete transfer. This is sometimes refers to ASII among, for example, the state component of ASP.NET uses base 64 encoding to safely transmit text via HTTP post in order to avoid detrimental pollution. Encoding standard. The 95-inch imprint codes 32 to 126 are known as ASCII portable characters. Some are older and today uncommon formats include BOO, BTOA, and user encoding. Most of this encoding generate text containing only a subtext of all ACII portable characters. For example, the base 64 encoding generates text that only contains upper cases and lower cases letters. A to Z, small a to Z, numericals 0 to 9, and the plus slash and equals to symbols. Some of these encoding are based on set of allowed characters and a single escape character. The allowed characters are left unchanged, while all other characters are converted into a string starting with the escape character. This kind of conversion allows the resulting text to be almost readable in that letter and digits are part of the allowed characters and are therefore left as they are in the encoded text. This encoding product the shortest blank ASCII output per input that is mostly printable ASCII. Sometimes other encoding are based on mapping all possible sequences of 6 bytes into different printable characters. Since there are more than 26 equals to 64 printable characters, this is possible. A given sequence of bytes is translated by viewing it as stream of bytes, breaking this stream in chunks of 6 bytes and generating the sequence of corresponding characters. The different encoding differs in the mapping between sequences of bits and characters and in how the resulting text is formatted. Some encoding use 4 bytes instead of 6, mapping all possible sequences of 4 bytes onto the 16 standard hexadecimal digits. Using 4 bytes per encoding character leads to a 50% longer output than base 64, but simplifies encoding and decoding, expanding each byte in a source independently to encoded bytes is simpler than base 64, expanding each byte to 4 encoded bytes. Out of PETSCII, first number 192 code, 164 has visible represents when quartet 5, 15 to 20 and 28 to 31, 32 to 90, 91 to 127, 129, 133 to 140, 144 to 159. This theoretically permits encoding such as base 128 between PETSCII states machines. Note: not strictly a text encoding as output includes non-printable characters for arbitrary data. Encoding all 189 non-undecided characters with 3 bytes and these remaining 66 characters with 1. For text, only encoding each of 18 received characters one byte stored as equals to XX, encoding all but the 94 characters which do the here I coded the program. First, we are using the while loop and the for loop while coding this program. Conclusion. In C, the binary writers class is used to write primitive types as binary information to the string. If the encoding is not defined, then the binary writers class uses the default UTF-8 characters encoding to write data to a binary file. An object of binary writes can be created using this C project. Thank you.